Hello guys, welcome to the session. We are going to solve some questions on mole concept, okay, which is helpful in your JEE or NEET exams or any other like competitive exams, KPI, BITSAT, all those, okay. So we are going to see some problems based on mole concept here, right? So let's start this session. Okay, so the first question you see, the first question is this: calculate the molality of 1 liter solution of 93% H2SO4, density of solution is given. Okay, first of all, you see in the question it is given H2SO4, and it is 93%, right? Weight by volume it is given. What do you mean by this 93% weight by volume? This means we have 93 gram of H2SO4 in 100 ml solution. This is what it means. 93 gram H2SO4 in 100 ml solution, right? So obviously, since molality we need to find out. So molality is equals to what? Number of moles of solute divided by mass of solvent. If it is in gram, then into 1000. This is the formula we have. So number of moles of solute easily we can find out because mass of solute is given 93 gram. So number of moles of H2SO4 is what? It is 93 divided by molecular mass of H2SO4, that is 98 moles. Okay. Volume of solution is given and density is also given, 1.84. So what is the mass of solution? Mass of solution is equals to density into volume. So density is 1.84 and volume is 100 ml. So it means it is 184 gram, the mass of solution we have. So what is the mass of solvent? Because we need to find out the mass of solvent here. You see the formula. So mass of solvent is mass of solution minus the mass of solute, which is 93 gram. So this is 91 gram is the mass of solvent, right? So what we can write here, the molality is equals to 93 divided by 98 divided by 91 into 1000. This is the formula we have. Okay. Now when you solve this, you'll get around 10.42 molar. So answer for this question is this one. Okay. So what was given in this question? In this question, it was given that 93% H2SO4, weight by volume ratio is given, right? So first of all, to solve this question, you should know what is the meaning of this weight by volume. This means mass of solute divided by volume of solution into 100. So it means 93% means per 100 ml of solution, since volume over here, per 100 ml of solution, 93 gram of solute, that is H2SO4, is present. So when you know this formula of this molality, moles of solute by mass of solvent in gram. So you need to find out moles and mass of solvent. Moles we know, since we know the mass of H2SO4, we can find out moles by this formula. Mass of solvent is equals to, we know, mass of solution minus mass of solute. Mass of solution we can find out by density into 100 ml of solution. You get 184 and this. So this is the answer for this question. Easy one is this. Okay. I hope all of you have understood this question. Fine. Yeah. Let's move on to the next question. The next question is 0.50 mole of BaCl2, right? 0.50 mole of BaCl2 is mixed with, just a second. Yeah, 0.50 mole of BaCl2 is mixed with 0.20 mole of Na3PO4 and this form. So what is the reaction here first of all? The reaction is BaCl2 plus Na3PO4. This gives Ba3PO4 whole twice plus NaCl. This is the reaction we have. Now, first of all, what we need to do, we need to balance this reaction. So 3Ba we have here, so 3 I'll multiply here. Okay, PO4 we have twice, so we'll multiply this by 2. This side, this is balance, 6 Na and 6 Cl, so we must have 6 over here. Now from this equation, what we can say, the relation is 3 mole of BaCl2 combines with 2 mole of Na3PO4 and gives 1 mole of Ba3PO4 whole twice. Right, since in the question it is for Ba3PO4 whole twice, right? Hence, I am taking only this. You can also say 6 moles of NaCl forms. Okay. So, what is given in the question? The data given in the question is we have 0.5 mole of BaCl2 and 0.2 mole of Na3PO4. Then what is the moles of Ba3PO4 forms? This we need to find out. So in this question you see Na3PO4 is the limiting reagent. If you find out the limiting reagent, because 3 moles requires 2, right? So 0.5 moles requires, number of moles for Na3PO4 is more over here, right? So 0.5 moles of BaCl2 requires, if you see, requires 2 by 3 into 0.50 mole of Na3PO4. So this value is what? This value is what? 1 by 3. That is 0.33 approximately mole of Na3PO4 required. But in the question, it is only 0.2 mole given, right? So the number of moles of Na3PO4 in the given question is lesser than what is required. That's why this Na3PO4 will get consumed completely, and hence it is the limiting reagent of the reaction. So what we can say, 2 moles of this gives 1 mole of this. So 0.2 moles gives 0.1 mole of Ba3PO4. So number of mole of Ba3PO4 whole twice is half of 0.2, and that is 0.1 mole. Hence answer is option A. Okay, this is the question based upon the concept of limiting reagent. Okay. The next one you see, the percentage weight of zinc in white vitriol, the formula is given ZnSO4.7H2O, is approximately equals to, we need to find out, weight of zinc in this formula. Okay. So first of all, before solving this question, the information which is given here. First of all, what is given? ZnSO4 dot ZnSO4 dot 7H2O is what? This is white vitriol. This formula you should know. White vitriol. Right. The name also you should remember. Okay. Similarly, FeSO4, the hydrated form of FeSO4, we call it as green vitriol. Okay. FeSO4 is green vitriol. H2SO4 is one of the strongest acid we have. We call it as oil of vitriol. So similar kind of thing. Vitriol term is there. White vitriol is zinc sulfate solution. Green vitriol is ferric sulfate solution, FeSO4. Oil of vitriol is H2SO4. In fact, H2SO4, you must know, this compound we also call this king of chemicals. King of chemicals, right? Right. This information is not required to solve this question. Now, what is this question is all about? You see this question, the first one, question number 12. It says the percentage weight of zinc in ZnSO4. So we know the weight of zinc is what? 65 given in the question. So we'll find out the molecular mass first of all. The molecular mass of ZnSO4.7H2O, that is 65, plus sulfur is 32, oxygen is 16, plus 7 times 18, water. Right, when you solve this, you'll get the molecular mass of zinc is 287. Right, this is the molecular mass of the zinc. Now, out of 287, 65 gram is what? The mass of zinc. So what is the percentage mass? Percentage mass will be 65 divided by the total mass 287 into 100. And when you solve this, you'll get 22.65%. Right, option D is correct for this one. Okay. Question number 13, you see. The volume of carbon dioxide gas evolved at STP by heating this will be. Okay. So for this one also, you should know what is the reaction. Means what happens when we heat this bicarbonate. The name of this compound is magnesium bicarbonate. So when you heat this, obviously this bicarbonate converts into carbonate, water evolves, and CO2 also evolves in the form of gas. Okay. And you see the reaction is balanced. If it is not balanced, then we have to balance this reaction first. Okay. So what we can say, 1 mole of this gives 1 mole of Cl2. So we can say what? The number of moles of MgHCO3 whole twice, this must be equals to the number of moles of CO2. So the number of moles of CO2 is equals to 7.3, the mass of MgHCO3 whole twice, and the molecular mass of this, if you calculate, magnesium is 24, hydrogen is 1, carbon is 12. So 12 plus 1 is 13. 13 plus 16 into 3, that is 48. 13 plus 48 is what? That is 61. 61 into 2, 122. Right, 61 into 2 is 122. So 122 plus 24 gram of magnesium means the molecular mass of MgHCO3 whole twice, its molecular mass is 146 gram. Right, for this one, the molecular mass is 146 gram. Okay, so number of moles of CO2 is this divided by 146. And these many moles, if you want to find out the volume of CO2, is equals to 7.3 divided by 146 into 22.4 liter at STP. Because we know 1 mole occupy 22.4 liter. Okay, so when you solve this, it will be, or since the volume is given in ml, so I'll directly write down here the volume in ml, which is 22400. Easily you can solve this 2 times, and this is 1120. So option B is correct for this one. Right, 1120 ml of CO2 will get evolved in this reaction. Okay, so percentage mass or composition of any element present in any compound, we can find out by this method. Total mass you find out, and what is the contribution of that particular element in that total mass. Okay, out of 100, that would be the percentage composition. Okay, for this kind of reaction, you should know what happens when you heat these kind of compounds. So this is the prior information you should have to solve this kind of questions, correct? So like first of all, if now you see in this question what happens, the reaction is already balanced, correct? So you don't have to balance this reaction, right? If it is not balanced, then we'll balance the reaction first and we'll find out the molar ratio, and accordingly we'll do the question. Okay, next one. The next question is the amount of zinc, atomic mass is given, is necessary to produce 224 ml of H2 by the reaction with an acid. Okay, so remember here 224 ml of H2 it is given, but it is not given here the condition at STP. That is not given. Okay, but to solve this question, you have to assume the condition at STP. That is important. That is, you have, that assumption you have to do. So question number 14. The first thing is what? Assumption is STP. We are assuming a standard temperature pressure pulse. Okay, so the amount of zinc this is necessary to produce this, right? So obviously zinc can eliminate hydrogen gas from any acids like H2SO4. Zn plus H2SO4 gives ZnSO4 plus H2. Right. So when the condition is STP, you are assuming. So number of moles of zinc is equals to the given mass, which is which we do not know. Volume is given. So given volume, that is 224, divided by the molar volume, which is 22400. This is the number of moles of hydrogen. This is for hydrogen, not zinc. when you look at the reaction, how this zinc produces H2 gas, the possible reaction is this: Zn plus H2SO4 gives ZnSO4 plus H2. So 1 mole of this gives 1 mole of H2. Means the number of moles of zinc and H2 will be equal in this case. Even if you take another reaction like HCl, suppose you are taking zinc plus HCl, it forms ZnCl2 plus H2. So 2 moles of this you get. Again, you see 1 mole of zinc gives 1 mole of hydrogen. Right, 1 mole of hydrogen. So this information you should have, okay, that how this zinc produces hydrogen gas in this. Okay, so we can say the number of moles of hydrogen must be equals to the number of moles of zinc, and hence the relation is what? The number of moles is 1 by 100 is equals to the mass of zinc divided by atomic mass of zinc is 65. So the mass that produces 224 ml of H2 is 0.65 gram. Answer is option A. Option A. Okay. Easy one, right? So this, again, this kind of information you should have. Okay. Try question number 15. I'll take some water and come. Okay, the next question is question number 15. The number of atoms in 4.25 gram of NH3. Okay. Okay. So if you see, the concept of this question is NH3 molecule. If you take one single molecule of NH3, so there are 4 atoms into this. 4 atoms in one single molecule. So like this, if you find out the number of molecules, so that number into 4 gives you the number of atoms. So we need to find out the number of molecules first. So for number of molecules, we have to find out the number of moles, because 1 mole is equals to Na molecules. So the number of moles here is number of moles of NH3 equals to mass is 4.25 divided by molecular mass of NH3 is 17. Okay, so when you solve this, you'll get number of moles here is 0.25. So number of molecules or number of atoms, if I write down directly, is 4 into the number of molecules. So number of molecules is what? 4 into 0.25 into Na. So 4 into 0.25 is 100, that is Na, right? Hence the answer is Na number of atoms will be there. Answer will be approximately 6 into 10 to the power 23. Okay, so answer for this one is A. Okay, now question number 16. The number of molecules in 4.25 gram of own, just now we did. The number of molecules is nothing but 0.25 into Na, right? 0.25 into Na, just now we did it. I'll just write down the number of molecules (0.25) into Na. Na we are assuming 6. So 6 into 0.25 is 1.5, 10 to the power 23. So option again A is correct. Okay. So the correct answer of these three questions we have A, and A. Okay. Next question you see. What volume of hydrogen gas at 273 Kelvin and 1 atm pressure? What volume of hydrogen gas at 273 Kelvin and 1 atm pressure will be consumed in obtaining 21.6 gram of elemental boron from the reduction of boron trichloride by hydrogen? So reaction is what? We have reaction of BCl3 and hydrogen gives BH3. Oh, sorry. What volume of this? Elemental boron is B, HCl. Okay. So when you balance this, it will be 2 here, 3 here, and 2 here, 6 here. Okay. Now, it says 21.6 gram of elemental boron. So this mass is given 21.6 gram. So what is the mole we get? 21.6 divided by 108, 0.2 moles of boron, elemental boron forms in this reaction. We need to find out what volume of H2 gas required at this Kelvin. So So again, volume we have to find out. So we have to again assume here STP, because moles and volume relation we can only define at STP. Okay, we can say 1 mole of any gas occupy 22.4 liter at STP. Okay. So first of all, we'll find out what is the number of moles of H2 required for this particular reaction. So 3 moles gives 2. So for 0.2 moles, we require 0.3 moles of H2. 0.3 moles of H2. Okay. We know 1 mole is 22.4 liter. Right. 1 mole is 22.4 liter. So 0.3 mole is equivalent to 0.3 into 22.4 liter is equals to 67. Okay. Did I miss something else? Yeah, I have missed one thing here. Okay, the calculation is just a bit mistake over here. So we have this 10.8 is atomic mass now. So 10.8 means we are getting 2 moles. So just a correction, guys. We have 2 moles here. So this will also get corrected. So we have here 2 moles of this. So 2 moles requires 3 moles of H2 from the stoichiometric coefficient. And 3 moles of H2 is equals to 3 into 22.4. That is 67.2 liter is the answer, option D. Okay. You can also solve this question with the help of this. We can use PV is equals to nRT. You can also solve this way. PV is equals to nRT. And in this PV is equals to nRT, you have to substitute the pressure and temperature as 1 and 273 Kelvin because it is given. Okay. So the condition is given like this. And if you observe this, this is the condition of STP only. Right. And that's why I have taken this volume, because this is the volume of 1 mole at STP. Condition is that. If you do not realize this, or suppose some other temperature and pressure is given, then we can use this formula. PV is equals to nRT. So volume we need to find out. So what we can write, B is equals to N is 3. Here we get R is 0.0821. Whatever temperature is given, here it is 273 by whatever pressure is given, 67.8 liter is the answer. Okay. So directly you can consider STP, which is given in the question, and you can solve this easily. Okay. If suppose the pressure and temperature is not according to this condition STP, then we have to use only this particular way. PV is equals to nRT. Okay. Question number 30. A compound has hemoglobin-like structure. It has only Fe. It contains this percent of Fe, the approximate molecular mass. Okay. So a compound has hemoglobin-like structure, has one Fe, only one iron atom is there. Okay. So we know if 56 gram is the atomic mass of iron. Atomic mass of iron. Okay. So 4.6% is equivalent to the molecular mass. 4 we can write 4.6 gram is the mass of Fe if the molecule has 100 gram of mass. Okay, if the compound you take 100 gram, then 4.6 gram is the iron present into this. So 1 mole, we know the compound has 1 Fe atom. So 1 Fe atom, the atomic mass is iron. So for 56 gram, what is the mass of the compound? That is 100 by 4.6 into 56. Okay. Now when you solve this, you'll get 5600 by 4.6, and that is approximately 1217 gram per mole. So answer is approximately 1200 as per the option given. Okay, the nearest possible answer is option D. Hence the answer for these two questions you see, it is option B for this one and option D for this one. Okay. An organic compound containing carbon and hydrogen has this percentage of carbon, its empirical formula. Okay, so there are various different methods we can do this question. Okay, the first one is what? Suppose we have 100 gram of the sample, right? 100 gram of the sample. So in 100 gram, we have 92.3 gram of carbon. According to the question, it is 92.3 gram. It is 7.7 gram. Okay. So number of carbon atom in this is what? 92. This is for carbon and this is for hydrogen. So number of carbon atom is 92.3 divided by 12. And this is 7.7 divided by 1. This value is 7.69 you get approximately. And this is 7.7 only. So this value, when you find out the relative whole number ratio, this will be for carbon, it will be 1 relative whole number because this divided by this, both values are equal only, right? 7.7 you can assume like this. So we can directly write this as 7.7. So hence the empirical formula will be CH. That is the empirical formula. 1 carbon atom and 1 hydrogen atom. You can also do this by one method. Since the percentage mass of carbon is given, so you can find out the percentage mass of carbon in each compound. If it is coming out to be this, that is the answer for the question. Like, so for example, the first one, if you take CH4, if you take CH4, so its percentage mass of carbon is 12 by total is 16 into 100. So 300 by 4. And that is around 75%, which is not the case in the option. Hence this one is not correct. CH3, if you take 12 by 15 into 100, right? So it will be 400 by 5. 400 by 5, that is 80%, which is also not correct. If we take CH2, 12 by 14 into 100, 600 by 7, So it is around 85%. Correct? So none of the option is close to 92.3%. But when you calculate CH for CH, 12 by 13 into 100. So 1200 by 13, so that would be what? 92 point something you are getting here if you solve this. And that's why the answer is option D. So 1:2 you can calculate by this, find out the relative whole number of ratio of carbon and hydrogen, and according to that you'll get the empirical formula. Other thing, for all the options you calculate the percentage mass of carbon present into this. Right? Only one option will match with this particular value. That will be the answer for your question. Okay. So two methods you can use, by option and by the process. Okay. I would suggest you to always consider the option condition, option wala method, right? This you can check, you'll get the answer. You'll get the answer actually, you don't have to check all the options here. You'll have the idea that what could be the possible answer, and then for that one you can cross check. Okay. Next one you see. Four grams of copper was dissolved in concentrated nitric acid. Okay. 4 grams of copper was dissolved in concentrated nitric acid, and that is Cu plus HNO3. The copper nitrate on strong heating gives 5 grams of its oxide, the equivalent weight of copper. Okay, the equivalent weight of copper you need to find out. So we have 4 grams of copper present into this, right? And from this we'll get copper nitrate, CuNO3 whole twice, and which converts into CuO. What reaction we have, that is not clear. Okay, which converts into CuO, and for this the mass is given, that is 5 grams of this we have. 5 grams of this mass. Okay. Now, to solve this question, you have to assume one thing. Then all the copper has been converted into copper oxide, right? So we have 4 grams of copper initially, and in this copper oxide the mass is 5 grams. It means here the mass of oxygen will be what? Out of 5 we have 4 grams of copper. So 5 minus 4 is equals to 1 gram of copper, 1 gram of oxygen. So mass of oxygen in this one is 1 gram. So number of equivalent for oxygen, that will be mass divided by equivalent mass of oxygen is 8, and that would be the number of equivalent of copper, because we know when two elements combines they must have equal number of equivalents, right? And number of equivalents of copper is equals to mass divided by the equivalent mass of copper. Mass of copper we know that is 4 grams. So equivalent mass, when you cross multiply this, you'll get 32 grams. Hence, the answer for this question here is 32, option C. So for the two question you see, the answer is option D and option C. Okay. Now you see the next question. Okay. The next question we have, 500 ml of NH3 contains this molecule at STP. How many molecules of this is present of CO2 at STP? So since STP is given, it means the pressure and temperature is constant. pressure and temperature is constant. And it means we can apply Avogadro law here. Avogadro's law is applicable for gases, right? And it says volume and number of moles are directly proportional. Number of moles, it means we can take number of molecules. Okay, so first of all, we can write for NH3 V by N for NH3 is equals to V by N for CO2. Volume is 500. Number of moles is at this one is okay. These many moles is equals to these many molecules. So we can write the number of moles over here. So these many molecules of NH3 is 1 mole is equals to volume of CO2 is 100 and number of moles of this. So N is equals to, we are getting 1 by 5 moles. So these many moles, the number of molecules into Na, that is 6 point something. So answer is approximately C we are getting. Okay. So answer is approximately 1.2 into 10 to the power 23. Option C we are getting the answer. Okay. Question number 48. In the reaction this, when 1 mole of ammonia and 1 mole of oxygen are made to react to completion, then what happens? Okay. So reaction is given NH3 plus O2 gives NO plus H2. So we have 4 moles of this is given, 5 moles of this, 4 of NO and 6 of this. What is given in the question you see? We have one mole of ammonia, and we also have 1 mole of oxygen. Then what happens? Okay, so obviously 4 moles of ammonia requires 5 moles of this, right? So 1 mole requires 5 by 4 moles, right? Means the number of moles of oxygen requires more than 1 for the complete reaction, right? So here in this case, you see, oxygen is the limiting reagent here. Limiting reagent. When oxygen is the limiting reagent, it means this oxygen gets consumed in the reaction, first of all the oxygen will be consumed. So obviously option B is correct here. Limiting reagents, option B is correct. 1 mole of H2O is produced. Can we say that? Because 5 moles gives 6 moles. If it is in gaseous form, then only we can talk about this. 5 moles gives 6. So 1 moles gives 1.2 moles of H2O. Option A is wrong. Okay. So when you check each and every options one by one, option A is wrong, option B is correct because O is the limiting reagent. 1.5 mole of NO is formed. Again, 5 moles gives 4. So 1 moles gives 4 by 5, that is 0.8 moles of NO. This is also wrong. All ammonia is consumed. That is also wrong because there are some amount of ammonia left in the reaction. Hence, the answer for this one is option B. Okay, all oxygen will get consumed since the oxygen is the limiting reagent. Okay. Okay, let's see the next question. Okay, try this one. Arrange the following 1 to 4 in the order of increasing masses, and choose the correct answer. Okay, so which one has the more mass? Okay, so first of all, we'll find out the mass here. The first one in this question, one molecule of oxygen. We know any molecule of oxygen okay, the atomic mass is what, or the molecular mass is what? It is the mass of any molecule, right? So any molecule, the mass of oxygen is 32 gram. So one molecule of oxygen, the mass is 32 by Na. Okay, second one, one atom of nitrogen. Okay, so we have Na nitrogen atom, the mass is 14 gram. So one atom, the mass is 14 by Na. Third one, this gram molecular mass of oxygen. Okay, so 1 gram molecular mass, 1 gram molecular mass of oxygen is 32 gram. So 10 to the power minus 10 gram molecular mass of oxygen is 32 into 10 to the power minus 10. Fourth one is this gram atomic mass of copper. So 1 gram atomic mass of copper is 63.5. So 10 to the power minus 7 gram atomic mass of copper. 63.5 into 10 to the power minus 7. So when you compare all of this, obviously one will have the maximum, then we'll have 2, then we'll have 4, and then we'll have 3. Okay. Right. So order you see here, one will have the maximum, then we'll have 2, 3 and 4 if you compare. 10 to the power minus 7 if you do, so we'll get this, we can also write it as this. 0.032 into 10 to the minus 7. So obviously this value is more, then we have 4, and then we have 3. So 1, 2, 3, 4, it's not correct. Okay, only one option is there, which is correct. So I think this Is there any mistake? No, I think the answer is a bit different will be here. It should be 1, 2, 4, and 3. 1, 2, 4, and 3. This is the answer. So there is a correction in this question. Okay. Option B is the most close one. 1 will have the maximum. 4 should be here and 3 should be here. Answer is this. Okay. Correction in this question. Now, the next question is this one, 79th one. How many moles of lead chloride will be formed? Lead chloride will be formed from a reaction between this and this. So we have PbO and HCl. It forms PbCl2 plus H2O. So PbO is 6.5 gram. HCl is 3.2 gram. And PbCl2, the number of moles we have to find out. So first of all, the balanced reaction is this. And 6.5 gram of lead oxide, the number of moles, if you find out, it is 6.5 divided by 224, the number of moles. 208 is the atomic mass of lead. It is 3.2 divided by 36.5. So when you look at this, obviously the limiting reagent is what? The limiting reagent will be 3.2 divided by 72 plus 173, 3.2 by 73, and it is 6.5 by 224. So if it is obviously, the limiting reagent is HCl, and hence we can say 2 moles gives 1. So these many moles gives half of this. So this we have 3.2 divided by 36.5 divided by 2, number of moles of this PbCl2 we get. Okay, number of moles of PbCl2 we get. Okay, so when you solve this, the answer will be option how many moles of this chloride will be formed when a reaction between this and this? Moles of lead chloride forms reaction between this and this. 3.2 by this. Okay, so this will solve. There is 6.4 divided by 36.5. So it is around, suppose I have a 0 over here. So this will be 0.01 something. So it will be 0.01, close to 0.01. And the answer is 0.011 approximately you'll get. Okay, 0.011 moles of PbCl2 forms in this reaction. Okay, so this question is again the stoichiometry based question we have over here. In this question we have a correction. Right, the correct answer is this: number of atoms. Gram molecular mass means what? It is the mass of one Na molecule of that particular molecule, right? Na molecule, the mass in gram, that is the gram molecular mass, right? Na atom, the mass is the gram atomic mass. Okay, so this gram molecular mass of oxygen, this means what? 1 gram molecular mass of oxygen is 32 gram. So these many gram molecular mass, this into 10 to 32, right? So that's why the answer is this. So here in this question we have a correction, and here the answer is 0.011. Okay, so this is it for the today's session. Okay, we'll see some more questions in this chapter in the next session. Thank you so much.